This book is Korean translation of the book published as first edition. There is newer edition, different translator. This review is about the first edition of the book. If we program softwares, we focus on software side, such as programming grammar and syntax, how they are used all together to run successful compile. To program simple matrix calculation, for example, we focus on Cramer's rule, conversion of the matrix to C language, what headers should be included, what data type must be so, for loop is nested, and array variables. This is able to be learned without strong knowledges about hardware. We focus on how to convert real-world matrix calculative process into C program. However, how is it when we need to know deeper ways of understanding program compilation, for example, how C program is converted to B machine language, what are dependent on this process? The computer hardware is set of voltages high and low, Boolean value of binary notation is used to process and visualize it. The simple C program too should be converted as object file or ultimately binary stuff. In concerning the process of these technologies, the undergoing process should be known first, how hardware is interactive with software. CPU architecture and its working outlines are recommended to understand these internal processings. CPU has been evolutionized from its beginnings. The earliest electronic computers are specific circuit for specific functions. It is very tedious, hard-working, so programmable computer systems are invented, which means for general purpose, engineers can reconstruct computer systems by adjusting socket and plug. Engineers can connect electric cable to specific sockets to choose corresponding instructions. The more logic circuits added, the combination of them can reduce the number of sockets, they assigned different numeric code, and it becomes primitive form of binary form of digital processing and use of registers, and its associative assembly programming. We need to learn not only gist of programming, we need to see how internal processing in modern computer systems are undergoing, assembly language and its behavior can help the understanding. The commands such as MOV, add, JNZ, loop, and so on involve with the knowledge how CPU architecture prepares registers in their hardware, and CISC and RISC differences also could be associative knowledges. For more rates of performance, we need to know how computer can run processes in parallel or multithreading. It is similarly process strongly related with CPU architectures. There are many algorithms doing this, prefetch queue, and multi-thread technologies, so-called pipelining. We also could know the pipelining diagram can be applied to understand when concurrency is used in modern programming. It would be clear shot to know about how to visualize internal processing. There is also technologies to store instruction to cache mechanism. The registers are most fastest but expensive memory, cache is the next expensive, next fast memory, which can reduce the bottleneck due to the different processing speed between CPU and other components of computer system. The C compilers have their unique techniques on optimizing their performances to control this behavior too. When we do programming in C in terms of high-level programming, if we know the technologies like these, we can make program better optimized performances. Instruction set architecture is considered as assembly programmers only, but it is not so. The C programmers or other high-level programming programmers also should have been understood about ISA too. The ISA is defined in CPU architecture, and from limited definition of ISA are combined to do more sophisticated ones. As an example, if CPU has only one arithmetic method such as addition, it is defined as ISA, and multiplication is replaced to add numbers as number of multiplicative instructions. Modern ISA is more complex chain of instruction set. The knowledge about how these processes are executed, programmers can be more stronger, deeper mind engineers. The book Great Code is 3-volume sets of explaining these associations with very great clarity. Each volume has detailed view of the explanations. There was story that MIT students have very strong background of assembly conversion at their class. All university students should have same skills and their own version of explanation are taken. This book is one other version of the explanation, very clear and detailed view of these learnings. It starts with binary and hexadecimal conversions of data treated by hardware. If we have acquainted knowledges learned in high school, this book can be read by. It is very reliable book. Although some type mistake is in first edition, rest of the explanations are reliable, and while we trust the book, we can absorb the insight of the approaches this book is oriented. This book is translated edition, so if you can buy original English editions, it would be great reference for doing IT in Korean language too. Highly recommended book.